Good morning, good afternoon, good evening. Whenever you are watching this video, let me welcome you all to our channel Future Endeavors. Okay, so in the previous class, we have started about the structure of matter, and in that we have seen that every matter is made up of some molecules, and in turn, those molecules are made up of atoms. So, we have been discussing about the structure of the basic fundamental unit of matter, that is atom. Now, as you have known, an atom is made up of again further three subatomic particles: proton, electron and neutron. So, when you consider this, we have also discussed the nature of proton, electron and neutron. Protons were positively charged, having a certain mass. We have discussed in the previous class. Neutrons are neutral in nature with a certain mass, and electrons are negatively charged with a certain mass. Now, we have seen that the charge on an proton or electron, okay, so charge on proton or electron was having some value like this: 1.6 into 10 to the power minus 19 coulomb. Coulomb is the SI unit of charge. Okay, so this was the charge of proton or electron. If it is electron, then it is negative, and if it is proton, it is positive. Now, this value of charge 1.6 into 10 to the power minus 19 coulomb, this value of charge is regarded as 1 unit charge. So, if I refer that a matter have 2 units charge, it means that the charge present on that matter is 3.2 into 10 to the power minus 19 coulomb. Okay, so I am just writing it down. For example, 2 units charge, this means the value of charge on that particular matter or object or body is 3.2. Why 3.2? 2 into 1.6, 3.2 into 10 to the power minus 19 coulomb. Okay, so this is the basic unit of charge, 1.6 into 10 to the power minus 19 coulomb. Okay, now if you consider the mass of the proton and neutron, it was about 1.672 and 1.676 into 10 to the power minus 27 kg, nearly about same. And in comparison to that, the mass of proton was quite less, because you have to divide by further 10,000, then you get the mass of the electron. So, as this value of charge is regarded as 1 unit charge, likewise the value of the mass of the proton or neutron, if we consider the mass of the proton or neutron, mass of the proton or the mass of the neutron having almost the same value, 1.67, let us consider up to this point, into 10 to the power minus 27 kg, then this value 1.67 into 10 to the power minus 27 kg, this is regarded as 1 AMU. Now, what is the full form of AMU? Atomic mass unit. AMU full form is atomic mass unit. Atomic mass unit. Okay, 1 AMU. Now, in comparison to this, if you consider, so we can say that the mass of the proton or neutron is about 1 AMU. If we consider the mass of the electron with respect to the mass of this proton or neutron, it's quite low, because forget about the magnitude or the value, just consider the order of the magnitude. It is order of the power of the 10. If you consider, the mass of the electron was something like this: 9.1 into 10 to the power minus 31 kg. Now, if you consider, just leave out this 9.1 factor and consider this factor 10 to the power minus 31. So, this is about 10,000 times lesser than this power of 10 in the mass of the proton or neutron. So, in that respect, we can consider that the mass of the electron is negligible in comparison to mass of proton or mass of neutron. So, the mass of the neutron is considered to be about 0 AMU. Okay, mass of proton and neutron are considered to be 1 AMU. Mass of electron is taken as to be 0 AMU. So, we can neglect the mass of electron in comparison to the mass of the proton and neutron. Now, all these, so if we consider the structure of an atom, the major mass of the atom is due to the protons and neutrons. More the number of protons and neutrons, more is the mass of the atom. Now if we consider the structure of the atom, then how are these proton, electron and neutron located or oriented or arranged, you can also say. So how are they arranged? If you consider, see, it's about like this, it's about like the solar system. If you can consider our solar system, that is a sun at the center and all the planets are revolving around the sun. Okay, likewise in an atom it is considered that there is a central region where the protons and neutrons are present. This is a central region. Okay, and around these protons and neutrons are circular or elliptical orbits, like the solar system of our solar system. So these are the orbits in which the electrons are continuously revolving around the nucleus. Okay, so here are the electrons revolving in the around the nucleus in the definite orbits. So this is the structure of the atom. Okay, so this is the electrons. So if we consider these protons and neutrons, okay, the protons and neutrons are present within the nucleus, are present within the, where it is present? It is present within the nucleus of the atom. The central region of the atom where the protons and neutrons are present together is regarded as the nucleus. Okay, and if we consider these protons and neutrons, okay, the protons and neutrons are together, they are together called the nucleons. They together are called the nucleons. So is it clear? So together they are called the nucleons. And the electrons, they are found or they are present, they keep on revolving around the nucleus in definite orbits or shells. So the electrons can be found, electrons are found within the shells, or also they are regarded as orbits, shells or orbits. So this is the structure of an atom. We will be discussing about the discovery of the various subatomic particles and how this atomic arrangement have been concluded, okay, or how the scientists have come to the conclusion that the atom structure may be like this. Okay, so experiments still are going on. There can be changes regarding the structure still now also, but till now what have been discovered, we can consider the structure of atom to be something like this. So this is the structure of the atom. Okay, fine. Now, so I think the concept of atomic structure is clear. Okay, fine. Now these atoms, what happens? These atoms, as I have said in the definition, may or may not exist independently. So if they are not able to exist independently, what happens? They either combine with other atoms of similar kind of the same nature, or combine with atoms of different kinds also. So as I have said, so if atoms cannot exist independently, what happens? They combine with other atoms of same kind, or of different kind. Okay, or of different kind. Fine. So atoms, so if these atoms combine together with other atoms, then what they are called? They are called the molecules. So when these atoms combine to form a structure called the molecules. Okay, now the molecules may consist of atoms of same kind, then it is regarded as the molecule of an element. On the other hand, it is regarded as molecule of an compound. So same atoms, so they form molecules of elements, and different atoms if they have different atoms, then they form molecules of compounds. Okay, so I think the concept is clear here. We'll be discussing more about elements and compounds in the later classes. In this class, we'll be ending our class here. Okay, so till the next class, please do study well. If you have any query, mention it in the comment box. We'll be happy to solve the problem. Thank you.